Good morning, students. Today we are going to study about the Cartesian sign convention. It is the most important topic for us because it can be of 3 marks in your exam. Not only that, some of the examples related to these chapters are also depend on this, a law of this convention, right? So at here, Cartesian sign convention, in which you have to take a 4 quadrant, means you have to take a 2 axis, an x-axis and at here y-axis, which makes a 4 quadrant, a 1 quadrant, second one, third one and the fourth one, right? In this one, the x-axis shows the distance of your object or image according to the mirror, while the y-axis shows a height. As you know that if here it is a mirror, then the distance can be at like that, right? If the object is at here, then you have to find the distance of that object by this axis, right? While the height can be measured by the y-axis, and just because of that, we are taking a distance on x-axis and the height on y-axis. Not only that, you have to put a spherical mirror such that its poles should be overlapped on the origin. So at here the origin is here, and you have to put a pole exactly on it, and you have to put a mirror like that. Not only that, you have to put a mirror such that its reflecting surface should be towards the left side. Why? Because generally all the figures are ray diagrams which we have studied, in which we have taken a reflecting surface on a left side, right? So generally our reflecting surface in a left side, so we are putting a mirror such that its reflecting surface should be on left side, and we will study according to it. Not only that, I will teach you also when it is on the right side what will be the changes in it. But now we are just taking on the left side its reflecting surface such that we can easily put an object on the left side, right? So if the object is on left side, so if here it is an object, what you can say about the distance and height? Its distance is positive or negative. For that, you have to remember that quadrant and the value of x and y on that quadrant. At here, as you know that on this axis, here it is a positive side, right? While here it is a negative side for the x-axis. On the upper hand, there is a positive, while here it is a negative, which we have denoted by y dash, at here x dash, right? But you have to just remember, this side is a positive and the another one is negative. Upper one is positive while the down one is negative, right? So here it is the sides and the sign of them, right? According to it, at here on the first quadrant, the value of both x and the y, the first one is x, the second one is y, right? So the x is also positive and y is also positive. So any object on it here, the distance should be taken as positive. Not only that, the height should be also taken as positive if the object is in this quadrant, right? At here, the object is in a second quadrant, right? The object is in a second quadrant. According to it, the value of x is negative, while the value of height is positive. So you can say that the distance taken for this object as a negative, while the height for that object is taken as a positive. Understand? If the object is at here, in the downward direction, or you can say that it is inverted, during that what happen at here, both are negative. So the distance is also taken as negative. Not only that, the height of that object should be also taken as negative. If the object is at here, both should be taken as positive. And if the object is at here, then distance should be taken as positive while the height should be taken as negative. Have you taken any decision some decision at here. What type of decisions are there? That you can see at here. All the distances which are on the right side of the mirrors are taken as positives. Right? At here, all the distances which are in the left hand side of the mirror is taken as negative. This type of decision should be taken by you when you study it like that. When you have the knowledge like that, you can take that type of decision also. You does not need to only think about which quadrant and something like that. You have to take a easy way. What is that? If the reflecting surface is on left side and all the distances on the left side should be taken as negative. All the distances which are on the left side should be taken as negative, and all the distances on the right side of the mirror should be taken as positive. What's about the height? Height above the principal axis, the x-axis which is passes from the pole, an imaginary line which is known as principal axis. So according to it, you can say that the height above the principal axis should be taken as positive, while below the principal axis should be taken as negative. So, at here, you can say that the distances on the left side are negative and the distances on the right sides are positive, while the height above the principal axis is a positive while below the principal axis are the negative. Understand? So here it is a Cartesian sign convention. The actual thing is that, according to it, the actual thing is that when the ray is incident from the object, it will go in this direction, like that. It just strike on a mirror, on this direction. So, the direction of incident ray is it in this one. Right? Okay, if you want to measure the distance of this one, what you have to do? You have to put a zero of a scale on the pole, and then you can easily measure the distance. The distance is measured in this direction. If you want to measure the direction of object at here, then you have to put a zero at here and just measure a distance, which is exactly on the opposite direction. So actual law is that you have to take a distance positive which is in the direction of incident ray, which is measured in the direction of incident ray. All the directions which are in the direction of incident ray should be taken as a positive. Here it is the direction of incident. And just because of that, all the distances on the right sides are positive, because it is the direction of incident ray. And if you want to measure that distance, you have to put a zero at here and you are just measuring in this direction. So it is taken as positive. But at here, if you want to measure this one, then you have to put a zero at here, and all the integers like a 0, 1, 2, 3, 4, 1, 2, 3, 4 are taken as in this direction. So it is opposite to the incident ray. So you have to take that all the distances as a negative. That's the law for the distance sign. For the distance sign of that mirror. So if you want to know the direction of that object or a distance of that object, then it should be taken as a positive or negative. It depends on the direction of incident ray. Right? In the direction of incident ray, all the distance, measured distance, should be taken as positive, and in opposite direction, you have to take it as negative. But for easy way, I am just giving you that. If it's in a left side, the reflecting surface is in left side, so all the distances on the left side should be taken as negative, while all the distances on the right side should be taken as positive. Or more easy that the distance of object is always negative. The object distance is always negative, because object is always on the side of reflecting surface. If you want to measure that distance, you have to take the opposite direction to the incident ray, because ray will be comes from the object. So it will go in this direction, and if you want to measure that one, it is always in opposite direction. So object distance should be always taken as negative. And if an image formed on this side, then you have to take the distance of that image as also negative. But if the image is on other side of the mirror, then you have to take it as a positive, according to Cartesian sign convention. Right? It is also the law for that, but it is easy to understand for you. The law is there. If you want to take the positive distance, then you should know about the direction of incident ray. Right? But for the easy way, you have to just remember that the object distance should be always taken as negative, and all the distances which should be measured in the side of a object, you have to take all of the distances as a negative, but on the other side you have to take it as a negative. And of course, in a height above the principal axis they are positive, and below the principal axis they are negative. So here it is the Cartesian sign convention, an easy way to understand for your sums. But if you want to write this one, this theory, then you have to know the law of it, or you have to write that laws. The first one is that all the distances should be measured from the pole of the mirror and parallel to the principal axis. You can't measure if the image is like that. Then you can't measure that image like that. Okay? You have to just measure like that, a parallel to the principal axis. If you want to measure the distance of image, you have to take parallel to the principal axis and then you can measure it. Not like that. Understand? So you have to measure all the distances from the pole only. 0 should be on the pole, and then you have to measure the distance of it. Right? So from the pole and parallel to the principal axis, the first one is that all the distances should be measured from pole of the mirror and parallel to the principal axis. Understand? The first one, all distances should be measured from pole of the mirror and parallel to the principal axis. Here is the first one. The second one, distances in the direction of incident ray parallel to the principal axis taken as positive. The distances which are in the direction of incident ray, at here according to this figure, you can say that the incident ray is in right side. The direction of that is in right side. So you have to take the direction as a positive. The same is at here. The distance in the direction of incident ray parallel to the principal axis taken as a positive. And the distance in opposite to the incident ray parallel to the principal axis taken as negative. If it is in the direction of incident ray, you have to take it as a positive, and in the opposite side you have to take it as a negative for the distance. Okay? And for the easy way, the object distance should be taken as always negative, and if the image is on that side where the object is situated, then you have to take that one as also a negative. So here it is the 3 law. The fourth one. What is the fourth one? The fourth one is that height above the principal axis, above the principal axis, perpendicular to principal axis, taken as positive. All the heights which are above the principal axis should be taken as positive, but if you want to measure it, you have to measure exactly perpendicular to the principal axis. Objects can't be like that. It should be perpendicular to the principal axis, and you have to measure that object perpendicular to the principal axis, and if it is above, you have to take it as a positive, right? And height below the principal axis perpendicular to principal axis taken as negative. The height which is below the principal axis should be taken as negative. Not only that, you have to measure that distance which should be perpendicular to that axis. Understand? So here is the file of Cartesian sign convention, in which first of all the distances should be measured from the pole and parallel to the principal axis. On the left side or opposite to the incident ray should be taken as positive, and the distances on the side on the direction of incident ray on the right side should be taken as positive. Okay? Above the principal axis should be taken as positive for the height, and below one should be taken as negative, which is perpendicular to the principal axis. So here is the phi law according to Cartesian sign convention. If at here you can see that on the left side distances are negative, on the right side distances are positive. But if I am taking a mirror like that, a reflecting surface is on right, then they becomes laterally inverted. Their sides becomes changed. Height will not. Above the principal axis, height is positive. Below the principal axis, height is negative. But as I said, always the object distances are negative, right? So at here, if you take the object at here, you have to take this distance as a negative because the reflecting surface is on that side. So object should be negative. And if the image is formed at here, it is also negative. But on the other hand, you have to take it as a positive. Understand? If it's a convex mirror, reflecting surface is on left side, so you have to put an object on the left side. If you put an object on the left side, the distances on the left side should be taken as negative and the right side should be taken as positive. So you have to remember that the object distances are always negative, right? If you put it on a left, then the left side is negative. If you put it on the right, then the right side should be negative. But it depends on the reflecting surface. If the reflecting surface is on left side, then only you can put an object on that side. Otherwise not. If you put an object on this side, right? The reflecting surface is on other side. Then how the image can form, right? So you have to put an object on the reflecting surface, on the side of reflecting surface. Then you can take all of the distances according to the Cartesian sign convention, because then and only then the image can be formed by this law. According to this law, you can take a positive or negative value for that image, for that object, height or a distance. So here is the most important topic for you. Now the other one. Now the other topic is mirror's formula. First of all, the definition of mirror's formula. The relation between object distance image distance and focal length is known as Miller's formula. The relation between object distance, image distance and the focal length is known as Miller's formula. The object distance is generally denoted by small u. Image distance is generally denoted by small v. And the focal length is generally denoted by small f. The relation between object distance, which is u, image distance, which is v, and the focal length, which is f, is known as Miller's formula. The formula is that 1 upon u plus 1 upon v is equal to 1 upon f. If you want to write this formula in word, then you have to take the reciprocal of object distance and the reciprocal of image distance. The addition of both of them gives you a reciprocal of focal length. The addition of reciprocal of object distance and reciprocal of image distance is equal to reciprocal of focal length, which is known as Miller's formula in the word, right? Here is the definition for the Miller's formula. Here is the Miller's formula, a mathematical equation, and here it is the Miller's formula in a word, right? Sometimes it can be also asked, also, right? You have to remember this formula because the sums are related to this formula. You have to use this formula for the sums, okay? And the last one, okay? Last topic for today is magnification of an image. Magnification of an image. What is the magnification? Generally, it shows you an image is how much bigger than the object or how much smaller than the object, right? So it gives you a right way to know the height of image, which is related to the object. Is it bigger or is it smaller? Understand? The formula for it is the magnification is generally denoted by small m. It is generally denoted by small m. And the formula is h dash by h. At when the h dash is image height of an image, while the h is object height of an object. So according to this formula, what is the definition of it? The ratio of image height to the object height is known as magnification. Of an image. And here is the formula of magnification. There is also another formula, which is m is equal to minus v upon u. At where you know that the v is a image distance and the u is equal to object distance. So here is the second formula of the magnification of image, and you have to use both of the formula in the sums of mirror formula, right? So there is a three formulas related to the mirror. The first one is the mirror's formula, which is 1 upon u plus 1 upon v is equal to 1 upon f. For the magnification, there is a m is equal to h dash by h and the m is equal to minus v by u. You have to take all of them, u, v, f, according to the Cartesian sign convention. You have to take all of them as a positive or a negative according to Cartesian sign convention. V can be a positive or a negative. U can be a positive or a negative. And the F can be a positive or a negative. But for that you have to apply the law of Cartesian sign convention. Then and then you know the actual sign of their all types of distances or height which are related to the spherical mirror. Then you can easily calculate a sums related to it. So just remember all of the formula and that Cartesian sign convention. Thank you.